Okay, set 78, Algebra 2, force vectors at a point. So we start with this problem. You have two ropes pulling in different directions. One of the rope is 70 units long at a 45-degree angle. The other is 40 units long at a 30-degree angle. And we need to find the resultant force. So the first thing we do is just draw corresponding right triangles, and we're going to use some trigonometry to find the missing parts. So we have four missing parts, A, B, C, and D. So we'll just use trig to find those A, B, C, and D's. So we'll start with A. We know we can use sine because the sine of 45, sine is opposite over hypotenuse. So we have A over 70. If we solve that, we get A is equal to 70 sine of 45. Sine of 45 degrees in the calculator is 0.7071. Multiply that by 70 and we get 49.47. So A is 49.47 units long. Now we'll do the same thing to get B. Now if you're quick, you can notice it's a 45 degree triangle, and when that's the case, A is going to be equal to B, but we'll just go through the motions here. Sine of 45 to figure out B, sine is opposite over hypotenuse, so we're using this 45 up here and doing opposite over hypotenuse, and we get B over 70. Multiply that out, B is 70 sine of 45, and at this point you can notice that it's exactly the same as what we had over there for A, so we can just copy our answer. B is 49.47. Now let's move on and find C and D. So to find C, we're going to do the cosine of 30. Cosine is adjacent over hypotenuse, so it's going to be C over 40. Multiply both sides by 40, you get 40 cosine of 30. Cosine of 30 is 0.866. Multiply that by 40, you get C is 34.64. So C is 34.64 units long. And the last part, we need to find D. So we'll use the sine, use opposite over hypotenuse, so we get D over 40. D is equal to 40 sine of 30. So that is equal to 40 times 0.5. Half of 40 is 20. So now we have all four pieces. We have A, B, C, and D. So here's our A, B, C, and D. And we'll just fill them in on the diagram really quick. So A, we notice, is going upward, so it's positive, it's 49.5. B, if we're starting here in the middle, B is actually going negative, so it's negative 49.5 because it's going in that direction. C is positive, it's going in the positive direction, so it's positive 34.64, and then D again is positive as well. So positive 20. So in order to write this in rectangular coordinates, we're going to take our two left rights and we're going to put them together. So going from left to right, we have negative 49.497 plus 34.64, and we get negative 14.857. Now we'll do our up-down forces, and that is 49.5 and 20. Add those together, you get 69.5. So now if we write out this rectangular coordinate, we get negative 14.857 to the right and 69.5 up. Now unfortunately we need our answer to be in polar coordinates, not rectangular coordinates. So we're going to have to do a little bit more work. So we'll take our rectangular coordinates and we'll draw a diagram that goes negative 14 and to the left, and then up 69.5 units. And we're going to have to find a couple of things here. The first thing that we're going to need to know is that angle right there. And then we're also going to need to know the length of the hypotenuse. So in order to find that big angle, we're going to need to find this little angle theta. So in order to find the little angle theta, which is this angle right here, we're going to do tangent. Tangent, remember, is opposite over adjacent. So the opposite of theta is 69.5 over adjacent, which is negative 14.857. We get tangent theta is equal to 4.677. Do the inverse tangent of both, and we get theta is equal to 77.93 degrees. But that's not exactly what we wanted. We want 180 minus 77.93 degrees, because what we really want is this other piece. We want this angle here. So that angle is 102.07. And so we know that angle is 102.07. Now we need to find the hypotenuse. The easiest way to find the hypotenuse is to use the Pythagorean theorem. Even though this doesn't really look like a right triangle, it's actually a right triangle, as we know. So we'll just use A, B, and C, the Pythagorean theorem. And we get c squared is equal to 14.857 squared plus 69.5 squared. Do that math, and we get c squared is equal to 5,051 square root, and we get 71.07. So the way that we write that in rectangular coordinates is 71.07 with an angle of 102.07 degrees. And that is our polar coordinate. Okay, so let's try another problem. Here you have two forces that are moving in the same direction. You have one horizontal force and then one going up at 30 degrees that is 16 meters long, or 16 units long. So the first part's going to be pretty easy with rectangular coordinates. We know that that is going 10 units to the right, and it's not going up at all. So the rectangular coordinates, we don't even have to do any math. 10 units to the right, and 0 units up. Okay, so now we just need to find the coordinates of that other that other triangle. So we're going to have to find B and C using trig. So we'll do the sine of 30. Remember, sine is opposite over hypotenuse. So we're going to find C over 16. C is equal to 16 sine 30. So C is equal to 16 times 0.5. Half of 16 is 8. So we know that C is 8 units up. Now we'll do the cosine of 30 to find B. So that's adjacent over hypotenuse. So B over 16. When we multiply both sides by 16, we get B is equal to 16 cosine 30. Cosine of 30 is 0.866. When we multiply that out by 16, we get 13.86. So B is 13.86 units across. So we take the coordinates of our second triangle, add them to the rectangular coordinates of that first rope, and when we add them together, we get 23.86 units to the right and 8 units up. That would be our solution in rectangular coordinates. However, we need to turn it into polar coordinates. So we'll draw a diagram of what this looks like. So we've got 23 units to the right and 8 units up, and we need to find that resultant angle and length. So the first thing we'll do is we'll figure out theta using tangent. So the tangent of theta is opposite over opposite over adjacent. Tangent of theta is going to be 0.335. Do the inverse tangent of both sides. We get theta is 18.54. So it's 18.54 degrees. Now we just need to find that hypotenuse. So we'll do that using the Pythagorean theorem. 8 squared plus 23.86 squared is our force squared, or our hypotenuse. So we get f squared is 633.3. If we square root, we get 25.17. So now we have our length and our degree. We just need to write it now. So our resultant is 25.17 with an angle of 18.54 degrees.